using our Secchi bucket, our Secchi sampling materials. Our Secchi sampling materials include the Secchi packet as well as this white bucket here that holds our equipment. So there's this longer rope, keep this out of the way. Once you're ready to start your Secchi sample, you're just going to pull this rope on top out in a couple of fistfuls and pass it to the side. It is imperative that we keep this line contained. This can easily and quickly get tangled in any of our sail handling lines or some of our hoses. So just be sure that when you're putting it to the side, you're not accidentally dropping it on any of our sailing lines. Once it's all the way to the bottom, you will pull out the Secchi disc. So these Secchi discs are ubiquitous in marine sampling as well as freshwater sampling. Jillian just told me the kind that they use in marine sampling is a little bit bigger and it's all white. But you'll notice that ours has this highly visible black and white pattern for us to be able to see it nice and easy. This is the exact same equipment that is used on research vessels all around the country. So this is a really great time to really show the students and really hammer home that we're doing real science on the boat. So we have the disc itself. On the bottom of the disc is a weight. This one in particular has a heavy lead weight. Some of them have some washers, but either way there is a weight on the bottom, so when we drop it in, it's going to be nice and stable like this. The way that we measure how far we're seeing into the water, so the way this works, we lower it into the water until we cannot see it anymore, and we keep track of distance with these pink lines right here. So these pink lines are 1 meter apart each. It is 1 meter from this disc to this line. And the way that we're going to introduce this to the students so that they can measure it, okay, is we count 1 meter when this pink line hits the water, okay? So if my arm is the water level, bloop, that's 1. It's not when it gets over the side of the boat, but when it hits the water. So you're going to lower this all the way down. Once you're finished, the students are going to pull it back over the boat. Make sure to be extra careful not to bang these into the side of the boat. Our captain and crew don't super love that. So just be respectful of the equipment, pull it up over the side, and then we're just going to make sure that this is contained over here for now. Again, make especially sure that we're not tangling this line anywhere. You will utilize the bucket to grab a surface water sample so we can get surface water temperature. It's a really important piece of data for inland seas to collect, so make sure that you are working to get that. And once you're finished, you're going to begin talking about what the Secchi disc reading really means. While that's happening, we know how to put the Secchi disc away. Now you're going to put the Secchi in first and then loosely feed this line in. There's no sense in taking the time to coil it around the side. We just kind of are spaghetti tossing this right in here. This is a great job to give to a student who might be feeling a little antsy. They need something to do with their hands. And that way your hands are free to explain some of the graph materials and charts and diagrams about, so that they can interpret their Secchi disc reading. I'm going to cheat. Don't do that on the boat.
For our outside demonstration, pretend that we're lowering the Secchi disc over the side of the ship, rather than over the side of the dock. Rachel in the yellow coat will be the student, and Jillian in the turquoise will be the instructor. Make sure to give the students each a role to play. One can hold on to the end of the line so we don't drop the Secchi disc into the lake, another can lower, and the remaining students can count as it's being lowered. Count out loud as a group as the meter marks hit the surface of the water. 1, 2, 3. This is what the Secchi disc looks like as it's being lowered into the water. The black and white contrasts, and you can see it very clearly. Once you can no longer see the disc, pull it back up and count the meter marks as they come out of the water to ensure that you have the correct measurements. As Rachel showed you earlier, to put the Secchi disc back, put the disc in the bucket first, and put the line on top. Again, there's no need to have perfect coils. As long as there's no knots and it's ready for the next instructor to use, you'll be just fine.
There are many helpful graphics in the Secchi packet to further explain what the students are seeing when we take a Secchi measurement. When using a chart or graph, be sure to draw students' attention to important parts like title, key, and the X and Y axis. This is all a part of the STEM curriculum. This line graph is one of the most commonly used graphs during the program. We have collected Secchi measurements in West Grand Traverse Bay since the program began in 1989, as shown on the X-axis. The Secchi depth is measured in meters, which is illustrated on the Y-axis. The title and subtitle tell us that each data point is an average of the measurements we take on the ship between May and October. The images of zebra and quagga mussels are near circled data points that indicate when those organisms were first found in the area. Using this information, we want students to recognize the trend in the data. There are many ways to have this conversation. Here is a way that I like to do it. Ask the group, in 1989, when we started taking the Secchi disc readings, what was our average? 6. And 1995? 8. What did we get today? This is a higher number, typically double digits in the spring. That's quite a difference. What do you see happening to our data? What is happening to this line? It's going up. Why do you think that is? Give them some time to point out the mussels. After these mussels were introduced, our Secchi readings went way up. The zebra and quagga mussels are filter feeders. When full grown, they can filter as much as 1 liter of water per day. All of this filtering is clearing the plankton from the water and giving us a higher Secchi reading. For further context, the plankton community clouds our fresh water. In the springtime, especially, we should get a lower Secchi reading because plankton are abundant with seasonal sunshine. We want the students to understand that the bay's clear water can be directly correlated with when these exotic mussels first appeared. Their filter feeding is clearing the plankton community. This graphic shows the density of quagga and zebra mussels in Lake Michigan. Quagga mussels are shown on top and zebra mussels are shown on the bottom. Darker colors indicate a more dense community of mussels. The red spots are areas where mussels were found but were not dense enough to warrant a blue color. Ask students what they notice. Immediately they are going to mention that the quagga mussels are more dense than the zebras. Indeed, the quagga mussels are more of a problem than zebra mussels ever were. This is due to a number of factors. For starters, zebra mussels need a hard substrate or surface to live on, while quagga mussels can tolerate nearly any surface. Further, quagga mussels can survive in deeper, colder water than the zebra mussels can. Where did the zebras go? Because the zebra mussels are less tolerant to cold water and soft substrate, the quagga mussels are outcompeting them. Basically, they are more fit to survive in Lake Michigan and are taking up all of the food and habitat. You may not have time to cover all of this material during the Secchi period. That is okay. The students will learn more about the mussels during the benthos learning station. This line graph shows the annual seasonality of Secchi readings from May through October. Unlike the first line graph, this one breaks down each year by month so that we get a better look at how the Secchi measurement varies during each month of the year. If I could draw your attention to the key on the right-hand side, notice the color difference between each year and find 1995. In 1995, we see low Secchi readings in the springtime and early summer, with an increase in clarity through late summer and fall. In more recent years, like the navy-colored line for 2018, that trend has switched entirely. This graphic is great to use with older students who are more experienced in reading graphs. It may be overwhelming for some of our younger student groups. All of this is important to our bigger story, that of the food web. During the Secchi portion, we want students to understand that plankton are the base of this food web. If the plankton disappear, the benthos organisms do not have anything to eat. And if the benthos organisms cannot eat and move away, small fish will not have food, and on until all of our organisms have gone hungry. This is also a fantastic segue into talking about how clear water does not necessarily mean that the water is healthy. Cloudy water in the springtime means that we have lots of plankton to feed other organisms. During Secchi sampling, students get to see how invasive species can affect our Great Lakes system. These non-native species can disrupt the way our system typically behaves and make life more difficult. Not impossible, because native species can adapt with time, but definitely more stressful for a period of time. Encourage them to keep an eye out for other invasive species as they explore the lake samples.